We are all living through this incredible AI boom. And, it feels like pure magic, right? Something happening entirely in the digital world. But behind every single one of those chatbot responses, behind every generated image, there's a massive physical crisis brewing. It's a crisis of power. And honestly, it's a trap we are all walking into. Let's break down how. So here's the fundamental problem, which some folks are calling a huge maturity mismatch. The AI software, the models and the algorithms, they evolve at lightning speed. We're talking breakthroughs in a matter of months. But the physical stuff needed to power them, the power plants, the transmission lines, all those transformers, that takes years, sometimes more than a decade to build. And that gap, right there, that's the core of the AI energy trap.
In this explainer, we're going to break down this whole unfolding story. First, we'll look at the sheer scale of AI's energy demand. Then, we'll see how the bottleneck has shifted from chips to the grid itself. We'll dive into a real-world crisis that happened in Virginia, and then explore how tech giants are now in this frantic race for power. We'll try to understand why compute is being called the new oil, and finally, we'll tackle the deep sustainability paradox that's at the heart of all this. So, just how much power are we really talking about here? Well, the numbers are frankly staggering, and they are completely rewriting energy forecasts all across the globe. Okay, so in 2024, data centers already chew up about 1.5% of all the electricity on the planet. But here's the kicker. AI is causing that demand to grow at a rate more than 4 times faster than all other global electricity consumption combined. The International Energy Agency thinks that by 2030, this little slice of the pie is going to more than double. And to get why this demand is just exploding, just look at a single query. A simple, standard search query uses a tiny little bit of energy. But a single query to a generative AI model like ChatGPT, whoa, it needs nearly 10 times the electricity. Now, just multiply that by the billions of queries that are going to happen every single day. You can see how the demand just goes vertical. This explosive demand has created a really fundamental shift in the industry. For the last few years, the big story in AI was the race for chips. But that's not the main problem anymore. Nope, the bottleneck has shifted from the silicon inside the server to the electrons that actually power it. I mean, just think back to 2021 through 2023. All the headlines were about the global chip shortage, right? But from 2025 onward, the conversation has totally changed. The constraint isn't manufacturing enough GPUs anymore. It's finding enough megawatts to even turn them on. The problem has literally moved from the server rack to the substation. Now, what's really wild about this is the timeline. You can't just build a data center and, plug it in. The lead times for the heavy-duty electrical gear you need are enormous. We're talking large power transformers can take 2 to 4 years to deliver. High-voltage switchgear, 2 to 3 years. And brand new transmission lines, you're looking at a decade, maybe more. So what does it look like when this digital demand just slams head-on into the physical grid? Well, there's no better example than Northern Virginia. It's the data center capital of the world. Something like 70% of global internet traffic flows through there every single day. In the summer of 2024, the grid in Virginia was pushed right to the brink. And after a near catastrophe, the North American Electric Reliability Corporation, NERC, they issued a warning that sent shockwaves through the whole industry. Because this wasn't some hypothetical problem. It was a real-world failure that almost plunged millions of people into darkness. And here's why. A single fault caused 60 data centers to simultaneously drop offline. The result was a sudden 1,500 megawatt power fluctuation on the grid. Now, to put that in perspective, that's like the demand of a large city suddenly vanishing. Grid operators had to pull off all these emergency maneuvers just to stop a cascade of blackouts. It was a massive red flag showing how fragile the system is. So what's the result of all this? The grid is just tapped out. Developers who want to build new data centers in the world's most important digital hub are now being told they might have to wait up to 7 years just to get plugged in. So, when the public grid can't keep up, what do? Well, if you're one of the world's largest tech companies, you take matters into your own hands. You stop just buying power, and you start making it. This has forced a brand new playbook to emerge. You've got Google, part of a $20 billion fund to build its own clean energy projects. Amazon is buying up data centers located right next to existing power stations. And in maybe the most dramatic move of all, Microsoft is actually helping to bring decommissioned nuclear plants back from the dead. Yeah, just let that sink in for a second. To fuel its AI ambitions, Microsoft has signed a deal to help restart a unit at the 3 Mile Island nuclear power plant.
This just shows you the incredible lengths these companies are now willing to go to secure the massive, continuous power that AI demands.
This race for power isn't just a business strategy anymore. It's actually reshaping geopolitics. And we kind of need a new way to think about global influence in the 21st century.
And that new framework is what people are calling the silicon-electron nexus. It's this idea that national power no longer just comes from armies or oil reserves. It comes from this deep link between having the most advanced chips, the silicon, and having the vast energy infrastructure, the electrons, to power them at scale. If you control this nexus, you control the future. In response, you've got countries all over the world just scrambling to build sovereign AI. They're all adopting different strategies to try and control their own computational destiny. Some, like the UAE, are trying to become these hubs that attract the big tech players. Others, like India, are leading with state-run programs to build their own AI infrastructure for public use. It is a truly global race to secure a piece of this new foundation of power. But there's a deep irony at the heart of this whole boom. The very same technology that promises to solve some of the world's biggest problems is creating a massive environmental challenge of its own. And that leads to the critical question of our time. Is a truly green AI future even possible? Or are the raw resource demands of this technology just fundamentally at odds with our global sustainability goals? To understand the scale of the problem, we've got to look beyond just energy. Meet WUE, or water usage effectiveness. This metric reveals the hidden cost of AI, the colossal amount of water needed to cool these massive computer clusters, which are running hot 24/7. So yeah, this energy crisis is also a water crisis. And the numbers here are just as shocking. By 2028, it's projected that U.S. data centers alone will consume 68 billion gallons of water every year. And here's the ultimate paradox. To chase clean solar energy, these data centers are being built in the sunniest parts of the country, deserts, where water is already the most scarce resource of all. So, we're left with this final, really challenging thought. The world of AI promises us this limitless digital abundance, incredible efficiency, solutions to our greatest problems, but all of it is built on a physical foundation of concrete, silicon, copper, and water. As we race into this future, the crucial question remains: can our physical world actually afford to pay the price